All right, our objectives are I will write a fraction that names part of a group, and I will write fractions that are greater than 1. Writing fractions that are greater than 1 whole. All right, let's get started. Writing fractions that name parts of a group. What does that look like? All right, let's look here. Jake and Emma each have a collection of marbles. Okay, as you can see, here's Jake's collection of his marbles, and here's Emma's collection of her marbles. The question asks us, what fraction of each collection is blue? That's important. So we're writing a fraction, so we need to make sure we have a numerator and a denominator. And we're writing that fraction of each collection that is blue. So let's first start with Jake's collection. All right, well, ask yourself, I'm going to count all of Jake's blue marbles. Well, I see 1, 2, 3. 3 blue marbles. So that is our numerator because we are being asked to write the fraction of the collection that's blue. So that's our numerator, our top number of blue marbles. And boys and girls, Jake has 3 blue marbles out of how many marbles in all? Well, let's count all of the marbles. That means we're counting all of them. All of the different color marbles in his collection because it still tells us the total number of marbles. 1, 2, 3, 4, 5, 6, 7, 8. So 8 represents our denominator. Total number of marbles. Okay? Well, let's see, write the fraction of the collection that is blue in Emma's collection of marbles in her group. Well, in this case, we're going to think, how many bags of blue marbles does Emma have? 1 bag of blue marbles. Okay? And there's a total of 1, 2, 3, 4 bags. So 4 is our denominator because that represents the total number of bags. Okay? So, what fraction of each collection is blue? Jake's fraction is 3/8, and Emma's collection of marbles that is blue is 1 out of 4, 1/4. Well, let's still look at Jake and Emma's collections of marbles, and this time, instead of writing a fraction of the collection that's blue, let's write the fraction of counters that are red. Well, let's look back at Jake's. All right, let's count the red marbles. 1, 2, 3. Okay, so Jake has 3 marbles out of a total of how many? 1, 2, 3, 4, 5, 6, 7, 8. The total number of marbles does not change. So the fraction of counters that are red in Jake's collection is 3/8. J for Jake. And what about, let's do Emma's collection. How many bags of Emma's marbles are red? 1 bag. Out of how many total bags? 1, 2, 3, 4. All right, let's practice some more. All right, what fraction of the counters are red? Let's look. There's 1, 2, 3, 4, 5 counters that are red. Here's my numerator. Out of how many counters in all? 1, 2, 3, 4, 5, 6, 7, 8. You still have to count those yellow counters because the denominator tells us the total number of counters. So the fraction of counters that are red would be 5/8. Let's look at a couple more. Write a fraction to name the red part of each group. Well, here's a group of apples, as you can see. How many apples are red? 1, 2. Out out of how many apples in all in the group? 1, 2, 3, 4. So 2/4 of the apples are red. Well, let's look at these balloons. Again, we're writing a fraction. We're naming the red part. All right. Well, ask yourself, because it's already in a group, how many groups are red? 1. Out of the total number of groups of balloons. 1, 2, 3. So 3 is our denominator. 1 group of balloons that are red out of 3 groups is 1/3. Now, I want to go over fractions greater than 1. All of the fractions, all of the unit fractions we've been learning about, 1/2, 1/3, 1/4, and so forth, even fractions 2/3, 2/4, 4/8, all of these fractions that we've been working with lately, all of these fractions are less than 1. Less than 1 whole. Well, there are times where there are fractions that are greater, that are larger than 1 whole. So let's look at some of those examples. So sometimes a fraction can name more than a whole group. Here's a word problem. Daniel collects baseballs. He has collected 8 so far. He puts them in cases that hold 4 baseballs each. What part of the baseball cases has Daniel filled? All right, so what part of the baseball cases has Daniel filled? So think of, when it asks us part, we're thinking about fractions. Well, let's look. Think about Daniel's cases. 1 case equals 1 whole. Okay? So one of his cases, here's 1 case of baseball cards. Here's his second case of baseball cards. Again, the question says, what part of the baseball cases has Daniel filled? Well, Daniel has 2 full cases of 4 baseballs each. So we can think of 2 as our whole, 2 wholes, because there's 1 case and the second case, or we can think of this as 8/4. 8/4. These are the same. Now let me show you how do we get 8 out of 4. 8/4. We use pretty much division, boys and girls. So you ask yourself, well, we get 8/4 because we have a total of how many baseball cards? There's 8. 4 plus 4 is 8. So the numerator represents the total number of baseballs. The denominator in this case represents the number of baseballs in each group. As you can see, there is 1, 2, 3, 4 baseballs in each group. And 8/4 equals 2. And we get the 2 wholes. Because you ask yourself, how many groups do we have? How many cases? 1, 2. So 8/4 is the same as 2 wholes. Now let's practice a couple more. Alright, so let's look at A. It says complete the whole number and the fraction that's greater than 1 to name the part filled. Well, think. 1 pan equals 1 whole. How many pans of muffins do you see? 1, 2, 3. There are 3 holes, 3 whole pans of muffins. Or we can say, well, what's the total number of muffins, guys? There's 6 in this case, plus another 6, plus another 6, and that represents 18. So there's a total of 18 muffins. And how many muffins are in each group? 6 muffins. So that's why our denominator is 6. And again, 3 wholes represents how many pans, how many groups. Let's look at these packs of pencils. How many packs do you see? 1, 2. 2 packs of pencils. Well, how many pencils are there in all? That's going to be our numerator. 1, 2, 3, 4, 5, 6, 7, 8 in this group, and 8 in this group. That's a total of 16. 16 pencils in all. And how many pencils are in each group? 8. 16/8. And it's the same as 2 wholes. So that was practicing fractions of groups. Now here we're going to practice finding parts of a group using unit fractions. Audrey buys a bouquet of 12 flowers. 1/3 of them are red. How many of the flowers are red? So we are trying to figure out how many of the flowers are red. Well, we know our total number of flowers that Audrey buys, and that is 12, okay? And we know out of these 12 flowers, 1/3 of them are red, okay? So we just need to know how many flowers are red. So what you can do, so think, 1/3 of the flowers are red. So think of, look at our denominator is 3. So think of 3 equal groups, okay? 3 equal groups. I'm going to go ahead and draw 3 equal groups. And we know 12 is the total number of flowers. So we're going to divide our 12 into these 3 equal groups. 1, 2, 3, 4, 5, 6. It should be 3, right? 7, 8, 9, not 3, 4, 10, 11, 12. So what I did, I took Audrey's 12 flowers, divided them into 3 groups, and we need to figure out what fraction of the flowers are red. 1/3, we know, the word problem said 1/3 of them are red. So think, I'm going to circle this one group again, because think of it as this one group out of the 3, right? This, for 1/3, we're representing 1/3 of the flowers are red. So I circled just one whole group because it's one group out of the 1, 2, 3 groups. And ask yourself, how many, these are my roses, flowers. How many flowers are in this group? 1, 2, 3, 4. So boys and girls, how many of the flowers are red? 4 of the flowers are red. Now I'm going to show you how I did that again. We're going to practice some more. All right. So we're solving 1/4 of 8. 1/4 of 8. Now, so think of, I'm going to circle, look at our denominator is 4. So we need 4 groups. Circle, they already have the picture for us. So I'm making 4 groups, right? 4 groups of 8. Well, this is a 4th, this is the 2nd, 3rd, and 4. We want to know 1/4 of 8. How many are in this group? 2. So 1/4 of 8 is 2. All right, look at this one. 1/3 of 6. So look at our denominator. The denominator tells us how many groups. We should have 3 in all. So let me circle. This is a group, 2nd group, 3rd group. Okay, and we need to know only 1/3 out of a total of 6 flowers. So think of 1 group out of 3 would be, let's do this group. 1 group out of the 3 total groups, how many flowers are in each? 2. So 2 is our answer. Let's do one more. 1/6 of 12. So the denominator is 6, so we know we need to have 6 equal groups. 1, 2, 3, 4, 5, 6. Okay, because there are 12 flowers, and we only need to know 1/6 of the 12, out of the 12. So out of these 6 groups, 1, 2, 3, 4, 5, 6, we only need to know 1 out of the 6 because the fraction said 1/6. So I always start with the first one. Here's one group out of the 6. How many flowers are in there? 2. Wow, all of these answers were 2. And we will continue practicing in math class.